Hello everyone, welcome to SPSS 3, the chi-square test of independence based on chapter 16 in Yaki. This first part I plan to go over the basic understanding of chi-square test of independence and walk through Yaki's example, and then in part 2 actually walk through the assignment that you've been given for this particular course. So first of all, this chi-square test of independence, its objective is to determine if there's a relationship between two categorical variables. So categorical variables, recall, are those where you've got groups of individuals based upon certain characteristics. For example, gender, race, ethnicity, those types of things would fall into the category of categorical variables. There's data requirements for the chi-square test of independence. First of all, you're going to have two categorical variables that have two or more levels each. And then you're going to have counts of the number of individuals that are in each one of the unique groups that are formed by the intersection of those two categorical variables. There's two assumptions, which is very different from what we've looked at in the past in this course. The assumptions are really quite simple. First of all, that there's independence of observations, that you would have individuals that fall in only one particular group. In other words, they don't straddle between two different groups and fall in two different places, and that the individuals don't influence each other in any possible way. And then also that their frequencies within each one of these groups is 5 or greater. And as noted here, you can see if you happen to have a group that has a count that's less than 5, you can use something called the Fisher's exact test. So there is a way around that even if you don't meet that particular assumption of the chi-square test of independence. So in comparison to the things that we've learned thus far in this class, such as the t-test and the ANOVA, there's some real differences between them. First of all, recall that when we perform a t-test or an ANOVA, we have one categorical independent variable that has two or more levels. In other words, gender, for example, you have male, female, race, ethnicity, subgroups. You might have Asian, African American, Hispanic, and white students. So you've got these different levels that form that one categorical variable. You also have one continuous dependent variable. Oftentimes we've talked about test scores or scores on a particular instrument, but any variable that happens to have equal increments between the values in it, 1, 2, 3, 4, 5, are examples of continuous variables. And typically in t-tests and one-way ANOVA, we're concerned with comparing the means of the groups. So we're looking at the means on the dependent variable of each of the groups and asking the question, are they different from one another? And t-tests and ANOVA are based on what's called a parametric analysis. We develop these sampling distributions. T and F and R, as you'll learn about, are examples of sampling distributions, and so therefore will these previous things are said to be parametric types of analyses. However, with chi-square, it's you've got two categorical variables instead of one, and no real dependent variable that's continuous. And what we're doing is we're comparing counts within these groups or frequencies of the individuals within those groups. And this is considered to be a non-parametric analysis because it doesn't use sampling distributions like we saw with our previous types of analyses covered in this course. So looking at the example from Yaki's chapter 16, he has two categorical variables, and he's asking the question, is there a relationship between them? So the data that's there for one categorical variable, which is called personality, is either people have been classified as either being an introvert or an extrovert. So those are the two groups that are related to, or the levels that are related to the personality variable. Then there's a second variable called preferred activity, and apparently individuals were surveyed to determine what type of activity they would like to engage in with others as part of particular organization. So they could select between going to an amusement park or they could choose going to a retreat. And so what you can do then is you can come up with a research question, and as is typical of Yaki, he'll ask this in the chapter, and he'll, in this particular case, the research question that could be addressed by this example is there a relationship between personality type and preferred recreational activity? Then, based upon that research question, you would have two hypotheses. The null hypothesis would be that there's not a relationship between personality and activity. And then the alternative hypothesis would be there is a relationship between personality and activity. So here's the data that he presents to you on page 201 related to this particular example. So over here on the left of this table, you can see we have the personality type, and there's two possibilities, introvert or extrovert. And you'll, in parentheses here, I've just put how these data have been coded in the data set. So if a person is an introvert, they would be coded a 1. If they're extrovert, they would be coded a 2. Then the second variable is their preferred recreational activity. And they had two choices, either go to an amusement park, which we've coded 1, or go on a retreat, which we've coded as 2. So I want you to look at the values that are inside here. So we can see the intersections of the columns and the rows, and these represent the counts of individuals within each of these two categories. So among the introverts, we had 12 that selected amusement park, but we had 28 that selected retreat. So 12 and 28, you can see the preponderance of the 40 total introverts in the group, they selected retreat over amusement park. Then here's our introvert group, which we've coded 2 in the data set. We can see there were 43 of them who said that they would prefer to go to the amusement park, while only 17 of the extroverts said that they wanted to go to the retreat. And over here you can see we had a total of 60 extroverts, giving us a total of 100 respondents. So you can see there's more extroverts than introverts. So it's kind of difficult to say, yeah, definitely the introverts like retreats more and the extroverts like amusement parks more. We might expect that based on what we know about introversion and extroversion. But what we need to do is to follow through with the analysis and determine if these numbers in these cells are truly reflect differences between personality type and the activities that they select. Also notice that under amusement park, there were 55 total people who selected amusement park and 45 who selected retreat. Now, it's nice that we have 100 here, so hopefully you can see that 55% of the people, 55 out of 100, selected amusement park, and 45%, 45 out of 100, selected retreat. Likewise, we have 40% of the individuals were introverts and 60% were extroverts. So what chi-square does is it takes a look at these numbers and it tries to figure out what we observed and compare that to what we might expect if there was not a relationship between personality type and recreational activity. So as I said, if we just look at down here, we can see that 55% of the respondents picked amusement park and 45% picked retreat. Okay, so what that means is that if personality didn't influence what people picked, in other words, if there wasn't a relationship between personality and recreational activity, then if we looked only at our introverts, okay, here's these 40 people, we might expect different numbers if there was not a relationship between personality type and retreat. Okay, so we can figure that out mathematically. So I can take those 40 total introverts and multiply that by the 55% overall who said they liked amusement parks. Okay, so if I had 55% of my introverts saying that, I would expect among the introverts that 22 of them would select amusement park. And likewise, I can do the same thing for the retreat. Here's my 40 total introverts and multiply that by the 45% of the people who overall said they would prefer a retreat. And so If there wasn't a relationship between introversion, extroversion, and the activity they selected, then I would expect there to be 18 individuals in this cell right here. So hopefully you see, based upon this, that there was actually 12, but I expected 22 to be there. And under the retreat, there was actually 28, but overall, I would have expected 18 to be there. So what I can do is I can look at the observed numbers and compare those to the expected numbers. All right, so you can see here observed was 12, and I actually expected 22 based on my calculations, and that the observed was 28. However, I only expected 18. So there's a difference between them of 10 here and 10 here. All right, so that's kind of important information to keep in mind. Now, I can do exactly the same thing for the extroverts. So here I had 60 extroverts, all right, and I only expected 55% of them to pick amusement park. All right, so you can see there, if personality did not make a difference in the activity selected, then among the extroverts, we'd expect to see 60 extroverts times 55% is only 33. So I would only expect 33 to be here, and I observed 43. And likewise for the extroverts, I would expect 45% of them to pick the retreat overall. However, only 27, or that correlates to an expected value of 27. However, only 17 actually selected that. All right, so what I can do then is I can take these observed values and the expected values and use that to calculate chi-square. And this is pretty much one of the simplest types of statistical analyses you can do. You can almost do it without a calculator. In fact, I used to have my high school biology students actually do these kinds of calculations in class. So as far as doing analyses, it's probably one of the easiest types of tests to understand the nuts and bolts of what's going on behind the scene. All right, so here's our table with observed and expected, and here's our actual formula for chi-square and how you calculate it. All right, so first of all, this big sigma symbol here represents summation. So I'm going to take, for each of these four cells, I'm going to take the observed frequency, and from that subtract the expected frequency, and then square that value, and then divide it by the expected frequency. So I'm going to do that for this cell, and this cell, and this cell, and this cell. And then this summation sign tells me that I'm going to add all of those together. So by plugging in those actual numbers, and Yaki provides this formula in his text, so you can see this 12 minus 22 is this 12 minus 22 observed minus expected squared, all divided by 22. Then we do that for this cell and the other two cells. And so you end up with these four values. Just crunch them by hand or with your calculator. Obviously, it would be easier, but it wouldn't be undoable by hand. And then add them all together. And once you do that, you should come up with a value of 16.835. All right, so then, in the old days, you would look up in a table in the back of your stats book, and it would tell you, what your what your p-value is, or whether you met p is less than 0.05 or 0.01. Of course, with SPSS, it's going to give you that actual p-value. But hopefully you notice that when the observed and the expected values are really large, you can see that that's going to increase the size of your chi-square. So there's a 10 difference there, and a 10 difference there, and a 10 difference there, and a 10 difference there. So that's 100 plus 100 plus 100 plus 100 in the numerator. And so you can see that those are pretty large numbers. If these numbers were pretty close to each other, if the observed and the expected weren't very far apart, then you're probably going to get a much smaller chi-square value. And so chi-square really depends on the difference between your observed and your expected. And as with our other test statistics, the larger chi-square is, the more likely you are to get a significant result. So if your chi-square was only 1 or 2, it may not be statistically significant, but something as large as 16 for chi-squares is a pretty large value. So we might expect that to be significant, at least at 0.05 or at a smaller level. All right, so that's the kind of the theoretical part behind the chi-square. The entering the data into SPSS is one part of the assignment and understanding how to do that. So in Yaki's example, he tells you to enter these data in there. So we're gonna walk through that process of what you need to do. So here's this so-called contingency table where we've got a 2 by 2, and we've got the one categorical variable and the other, and our counts there. Now, when we use this method and take these numbers and put it in there, we're going to use a special technique in SPSS, which is called weight cases. So basically, what you're telling SPSS is to count introvert and amusement park 12 times in the analysis. You're telling it to count introvert and retreat 28 times in the analysis. And likewise for the extroverts as well. So in a second, I'll show you how to do that by weighting cases in the system. So when you actually go to put these data using the frequencies method into SPSS, here's what your data might look like. Okay, so this first column here is personality, and remember we said that introvert was coded as a 1. So you can see here these first 2 rows, row 1 and 2, are 1s there. So those represent our introverts. And then down below that, rows 3 and 4, you can see those are extroverts because there's a 2 in each one of those rows under the personality variable. Then for activity, we've got amusement park, which is coded 1, and retreat that's coded 2. So right here, you can see activity is 1. So I know that means amusement park. So looking across row 1, this means that we've got introverts who chose amusement park. And then in our third column, we have our third variable, which is the frequency. And so I've put 12 in there representing the 12 people that are here. So for introverts who chose amusement park, we had 12 people. Okay. Using similar logic, we have in row 2, introverts who selected retreat, we have 28 frequency. Then under row 3, we have extroverts now because they're coded 2, who selected amusement park because they're coded 1 under activity, and then their frequency was 43 based on the table. And then finally, row 4 represents extroverts who chose the retreat, and we only had 17 people. So when setting up your grid for your assignment, you will need to put in some names of some variables here and include a frequency column. And so you will need to put the name of the variable in here. Just a note, you can't put any spaces in names of variables in SPSS. You can't start them with the number. Use all letters, keep it short, you know what it means. So they're fairly simple. These are pretty good examples of what you might use. So just a word to the wise moving forward with that. All right, so there's also another way. Besides the frequencies, we can do something called individual observation. And you might use this if you are collecting data from an online survey, let's say, and you are having people say, oh, I'm more introverted than extroverted, or they are taking a short survey or a short instrument that allows you to figure out whether they're introverted or extroverted. And then there's choice for amusement park or retreat. So you don't have them already aggregated. You might have a whole bunch of them, and you just want to run the analysis based on data that came right out of the survey. Okay, so what you can do instead of putting the frequencies for each groups, you can have individual observations. So here's the first person. All right, there's person number 1, and they said that they were introverted and they wanted to go to the amusement park. Here's person 2. They're also introverted and wanted to go to the amusement park. All right, so you might have a number of them. All right, so we would have 12 people like that. If these are the data here, we would see 12 records that look just like these 2. Now, Moving forward for this group over here, introvert and retreat, they would have a 1 for personality and a 2 for activity. And in this particular case, I would have 28 records that look like that. Then for the extroverts who chose amusement park, we would have 43 that look like this with a 2 under personality and a 1 under activity. And then finally, we would have 17 records that look like this that had a 2 for both personality and activity. So one of the things that I have you do in the assignment is to take a data file that has all this information in it for you. I'm not going to make you punch all that in, but to run the analysis using a, the individual observation method, just so you can see both ways that you can run this particular chi-square test. All right, so taking a look at the chapter 16 example, I'm going to walk through this um, in the Yaki text, walk through his example. So I've provided you in the assignment a data file called choice.save. There's another one called choice observation.save, which is the one that you'll use to do the other part, but I'll walk you through how to do that. So let me switch over to SPSS here and show you our frequency table here. So here I've set this up, and so this is basically how I just demonstrated to set up the frequency method of doing the chi-square test. And then our first step in here, once we set this up like this, is to go and weight the cases. So you'll go up to data, and if you look at the very last choice on the drop-down menu, it's weight cases. So what we'll need to do then is to tell SPSS how to weight them. All right, so you can see by default it says do not weight cases, but we do in this case want to weight cases. So we're going to weight cases by, and it's asking me for the frequency variable. All right, so again, we want to kind of trick SPSS into counting 1 for personality and 1 for activity. We want to trick it into counting 12 times. And personality 1, activity 2, we want to trick it into counting 28 times for that combination of personality and activity. So I'm going to select frequency and then move that over to the frequency variable. Okay. And so I've got the weight cases radio button selected and I put frequency there and then I click OK. So once I do that, you can see it's now says in my output file that it's weighting by frequency. Let me knock that down, and way down here in the lower left-hand corner, let me make this a little up a little bit so you can see it better. So you can see it says weight on. So that kind of tells you that it's got this weighting component back behind the scenes where it's weighting our data. All right, so once you've weighted the cases for our frequency data, then you can go ahead and you can run the analysis. So if you're following along with your Yaki text, you are on page 206, and he walks you through this. So we're going to go to Analyze, and we're going to select Descriptive Statistics, and we are going to choose Descriptives, and I'm sorry, we're going to choose Crosstabs. All right, so the crosstabs dialog comes up, and looking in the Yaki text on page 207 now, we are going to put personality on the rows and activity on the columns so that it matches up the way that we have our data set up, so that personality in the rows is either introvert, extrovert, and then the activity in the columns is either the amusement park or the retreat. All right, so once we've done that, then we are going to select statistics. All right, and there, as it shows on page 207, I'm going to select chi-square, and I will also select phi and Kramer's V, which is going to be our effect size. So we want to see what that is. And we're going to just ignore all the rest of this for now and select continue. Then we're going to click on cells. All right, so now under cells, I want the counts of the observed, and I also want the expected, okay, just so I can check this against the calculations that I already showed you. And then for under percentages, we'll select row as Yaki suggested there. And then once I do that, I'll select continue. And then once I've got all that set up, then I'll click on OK. And then our output should show us what the results of the analysis is. So we've got this case processing summary that we often have. It tells us whether there's any missing data there. So it tells us that 100% of the data were in there. Okay, then as we come down, we can see this is the main crosstab that was developed. So over here, we've got the personality, or introvert and extrovert, and across the top, our activity, amusement park versus retreat. All right, now there's a lot more rows in there than in my PowerPoint presentation. So we got to sort of dig out the counts. So here we can see the count was 12 for introvert and amusement park and 28 for retreat and amusement park. And going down to extrovert, there's our 43 and 17. All right, so there's the data from our counts that we put in there as frequencies. Then it tells us our expected counts. And not to go back to the PowerPoint, but you can double check my work there, that there was 12 and 22 were the actual observed counts and expected counts, and then 28 and 18, and where we go down to the extroverts, 43 and 33, 17 and 27. So those are observed and expected. Okay, so now it's telling me the percentage. So of these 40 individuals that that selected either amusement park or retreat, 30% of them picked amusement park and 70% selected retreat. All right, now if we compare that down here to the percents overall, we can see that 30% is much less than 55 and that 70% is much more than 45. So we've got this disconnect here between what we actually observed and what we expected. All right. So then overall down here, just kind of summarizes all that. It's kind of redundant and everything, but you can see our observed minus our observed and our expected. So then SPSS uses that information to plug into that actual equation for chi-square that I went over earlier. It gives us our chi-square value of 16.835. Okay. It says 0 cells down here at the bottom have a count less than 5. Remember, there's this Fisher's exact test. And here you can see how you could run that in SPSS, and it automatically does that for you if one of your cells had less than 5. Here is your p-value. You are used to it saying just sig there, but now they're calling it the asymptotic significance or two-sided. So this is actually your p-value for the Pearson's chi-square test. And under my older SPSS 25, it doesn't give me what the actual value is. It just says 0.000. This is always a point of confusion. How you would report that is p is less than 0.001. If you have a newer version of SPSS, I've noticed that it actually shows less than 0.001 now in those cases. So it shouldn't be such a big deal for you guys if you've got one of those newer versions of SPSS. Then down here under symmetric measures, it gives us our Kramer's V. Okay, so it tells us Kramer's V is 0.410 and it's significant. So this is our effect size that you would report when you do your APA write-up. All right, so that real quickly was going through the analysis for SPSS. And so what I will do is stop at this point, and we'll pick up with the second part for the chi-square test of independence.